Hi guys. Okay, so we're going to learn how to graph sine functions today. So back in chapter 3, we started learning about parent functions, which is the basic shape of the most common functions in math. So we had like the linear, the quadratic, the cubic, the rational, the radical, the step, or otherwise known as piece function. Oh, I'm trying to think what else there was. Exponential, log, but there really are 12 of them. So we have 3 more to learn, and one of them is sine. So I bet you can't guess what the other 2 are. But to start, let's learn how to graph sine. Okay, so we're going to graph y equals 4 sine over sine theta over 2, and it's just the theta that's over the 2. Okay, so looking at our steps that were in the notes previous to this, let's go through and work through those steps. This graph paper I will have linked on to the section, the lessons and all that. Like you usually have your A block format, which I know you guys all love that so much. I'll also provide this link for you guys so you can do this. It will really help you when you're drawing out your graphs. Okay, so we want to start by doing the aspects that were on the notes. So step 1, it said we need to find all these important pieces of this graph, okay? So part 1 was finding the amplitude. The amplitude is the number in front of the trig function as long as there's, no pluses or minuses. So in this case, it's going to be 4. Our period for sines and cosines is always going to be 360 or 2 pi divided by whatever we're doing to our theta. In this case, we're dividing it by 2, so that really means like we're multiplying by a half. So we need to divide by the half. 360 divided by 1/2, well, remember we can't divide by a fraction, so we're really going to multiply by the reciprocal, right? So 360 times 2, we get 720, okay? The graph paper is in radians. I've just done that over the years because I feel like it's something that most are not as comfortable with, radians. So kind of, forcing ourselves to do the better thing, which would be work with something that we're not too comfortable with and get more practice. So 720 degrees, let's get that into a radian. You could have done 2 pi right here and multiply it by 2 and known it's 4 pi really quickly. But like I've said before, I don't really think in radians, so I like to do degrees. So if I want to get this into radians, I need to multiply by 180 over pi. So I get 720 pi over 180, which is 4 pi, okay? So that means that my graph is going to repeat itself every 4 pi degrees or 720 degrees. Sine trig functions are cyclic, which means it has a pattern and it's going to keep repeating that pattern over and over and over again, okay? So we know that this graph is going to start repeating itself again in 4 pi. Sine graph, remember, goes to the origin, kind of looks like an S, right? So the distance between here and here is going to be our period, 4 pi, because what happens right here, it starts to repeat itself again. Okay, so that's all that means. We want to figure out where something important happens. And for us, it is these 5 points that we are going to be graphing. Because this is a cyclic graph, it's going to happen in the same interval. So what we can say right here is we're going to take our period and we're actually going to divide it by 4. Why 4? Even though there's 5 points that we have to graph, if you kind of remember your notes. We're going to graph our starting point. We're going to graph our ending point. Our ending point is like when a cycle starts to repeat. We're going to graph our middle point, and then we're going to graph these halfway points. Halfway between the start and the middle, halfway between the middle and the end. Okay? That's 5 points. So why are we dividing this period by 4? Think about the space in between these guys. In between the start and the halfway point, that's 1. The distance between the halfway point and the middle is 2. Distance between the middle and the halfway point number 2 is 3. Distance between halfway point number 2 and the end is 4. So we have these 4 spaces, but 5 points. So this will always be divided by the number 4, okay? Our period is 4 pi. And we're going to divide it by 4. So that means something important is going to happen every pi degrees. Okay, so every pi degrees, we are going to have a point. All right. Step 2 is plot our points. So we need to think. I always do this, guys, still after, I don't even know how many years I've been doing this. I always will graph what a little sine graph looks like really quick because sine and cosine look so much alike. Same with cosecant and secant when we get there, and same with tangent and cotangent. So it can be really confusing on where to start, okay? So let's do this. So we're going to start at 0. Okay, and then we're going to put our endpoint at the end of our period. And from step 2 on the amplitude or on the important aspects right here, we found out that our period was 4 pi. So we're going to have our start at 0 and our end at 4 pi. So all the way out here, and you guys can't see that. Okay, then we got to find our middle value. So well, the middle is halfway between these 2 points, right? So what's half of 4 pi? Well, that's 2 pi. And our start, our middle, and our end are always going to be, for sine, on the x-axis, or in any function, they're going to be lined up with each other, okay? They're all going to be right next to each other like that. Okay, this is a positive sine value, so I know my curve is going up, okay? We want to figure out where our first halfway point is. So we're working between 0 and 2 pi. So half of 0 and 2 pi is pi. But remember, this is a positive sign, which is why I draw this guy. So I know I'm making this point, this point, this point, this point, and this point. So I've done that one, and that one. Now I'm working on this one. So we know it's going to go up high. So halfway between 0 and 2 pi is pi. My amplitude is 4. So I'm going to go all the way up to 4. Okay. Same thing, halfway between 2 pi and 4 pi, well, that's 3 pi, and my amplitude is 4, but this time I got to go down 4. So we talked about dividing this thing by 4, right? The period divided by 4 for pi. So every pi, something important is going to happen. So we do this little pattern, and we were going to plot something in the center. We're going to plot something high. We're going to plot something in the center. We're going to plot something low. We're going to plot something in the center. We're going to plot something high. Do you see how it just keeps going and going and going? Because this is cyclic, it's a pattern, right? So we have center, high, center, low, center, what's coming up next? High. So we can continue this the other direction, and we know how far we have to go based on our period divided by 4, so every pi. So look at this distance. What? Between 0 and pi, I have pi, and I have a new point. And then I'm going to go out, what's pi and pi? 2 pi. Oh my gosh, there's another point. What's 2 pi plus another pi? That's 3 pi. Oh my gosh. Quinkydink? Nope. Okay, so now let's continue it the other direction. So it's happening every pi. So if I'm going 0 and I want to go left to pi, that's going to put me out to negative pi. I'm low, so that means I need to go center next. So negative pi, we're going to go out pi. I'm at my center. Going to go out another pi. I'm going to be high. And then go out another pi. I'm going to be center. Center, high, center, low. Center, high, center, low. Center. Do you see the pattern? Okay, then the last step is just to connect the points with a curve. And make sure you're making it a curve. It is not, oh, absolute value. That was another one of our parent functions. It does not look like this, okay? It needs to be a smooth, continuous curve. All right, and there's sine.